In this video, we're going to talk about the mole ratio and what that is. I want to recap with balancing. So the first thing we're going to do is balance this equation. If you remember, if we see H2O on one side and OH and H on the other side split apart, one of the things we can do to help us is rewrite this as HOH. And then we can go back in and balance it. We see that we have one Na on the left, one Na on the right. We have one H right here by itself, but we have two on the right. So we're going to go ahead and make that 2 here. That gives us 2 OHs and only one OH over here. So we can make that 2. And we have 2 NAs, 2 NAs, and then we should be balanced right here with a 1. When we've talked about equations, we usually mention the coefficients as atoms and molecules. But another thing that they actually represent are moles. So this equation actually reads 2 moles of Na plus 2 moles of water will create 2 moles of sodium hydroxide plus 1 mole of hydrogen. Therefore, what we can say is that our coefficients are also going to be moles. They're going to be the same thing. What this equation is saying is if you need 2 moles of sodium, you're going to require 2 moles of water. And that can make 2 moles of sodium hydroxide, and it can make 1 mole of hydrogen. So if we know that these things mean moles, then the mole ratio is the ratio between the number of moles of any substance in a balanced chemical equation. It has to be balanced because the coefficients are going to be what tell you the moles. So in the equation CH4 plus 2 moles of oxygen produces 1 mole of CO2 plus 2 moles of water, we can find several different mole ratios in this. First example would be for 1 mole of CH4, it requires 2 moles of oxygen. Another thing you could say is 2 moles of water are produced if 2 moles of oxygen are used. You could also say 1 mole of CO2 is produced when 2 moles of oxygen are used. The mole ratio comes from the balanced coefficients. Let's see if we can find the mole ratio in our balanced equation from the beginning. What is the mole ratio of sodium to hydrogen gas? We need to find sodium, so we have 2 moles of sodium, and then hydrogen gas is over here. Therefore, our mole ratio is 2 moles of sodium produces 1 mole of hydrogen. Let's see if we can find another one here. What is the mole ratio of sodium to water? We're going to locate sodium, and we're going to find water. And then the mole ratio comes from the coefficients. Therefore, 2 moles of sodium requires 2 moles of water. Now, why are mole ratios important? Why do they even matter? Well, mole ratios allow you to convert between the units within an equation. All we've ever really done before is convert between grams and moles and atoms. But you are actually able to convert between moles of one thing to moles of another. And you use the mole ratio within an equation to do that. We're going to go ahead and work an example right here. How many moles of D would 6 moles of A produce in the reaction 3A plus 2B yields 4D? Now what this is saying is A, B, and D are just some random elements. 3 moles of A plus 2 moles of B will produce 4 moles of D. What we're going to do is start with the given in our problem. Our given in this one happens to be 6 moles of A. We're going to write that down in the first part of our train track. Now the next thing we need to do is use the mole ratio with the unit you were trying to find on the top. What that means is we're trying to get to our desired unit. In this case, it's moles of D. But just like we've always done before, I'm going to bring moles of A to the bottom, and we're going to go to our desired unit on top. In the question, it says how many moles of D. Now, if you see mole over mole, one of the things I like to do is circle it, and then that reminds me to go find the coefficients from the problem. So moles of A is 3. Moles of D is 4. The last thing we're going to do is cancel out our units. Moles of A cancels out. It leaves us with moles of D. multiply the top, divide by the bottom. So 6 times 4 is 24, divided by 3 is going to be 8 moles of D. We're going to try one more example, this time using a real chemical equation. And this one says, if you start with 3.5 moles of Na, how many moles of H2 should be produced? The first thing we're going to do is start with our given. Our given happens to be 3.50 moles of Na. And then we're going to look for what we're trying to get to. So in this case, moles of H2 is what we're looking for. Whenever we want to cancel this out, we're going to bring moles of Na to the bottom, and we're going to go up to moles of H2 on top. One of the things I like to do is circle moles over moles. That reminds me to go get my coefficients from the problem. So Na, if we look up here, is 2. I'm going to write that in. And then H2 is right here. This one's going to be 1. Moles of Na is going to cancel out. I'm left with moles of H2, which is what we're looking for. If we multiply the top and divide by the bottom, then we're going to see our answer. 3.5 times 1 divided by 2 is going to be 1.75 moles of H2. And then we can check significant figures. Up here we started with 3, then in my answer here we have 3.